Greetings and welcome, friends. So we've talked about shapes of distributions. Today we're going to talk specifically about one shape, being the normal distribution. Actually, over the summer I did quite a bit of work with what was called a beta distribution, which, ladies and gentlemen, quiet please, which a beta distribution was a skewed distribution to the left or right. But we're going to work with normal distributions, which, by the way, spreadsheets can do such things, but that's not what today's about, alas. So it says, you have studied probability distributions. One type of probability distribution, actually, we haven't defined the word probability for you. That's okay. That's like the chance that something can happen. Don't worry about it. One type is called a normal distribution. The graph of a normal distribution is a bell-shaped curve called a normal curve. All right? And so here we go. Guys, good news about this for my friends here. I will let you have this graphic on our test. So you don't have to memorize all of those numbers. You are super welcome, because sometimes students have had to memorize some of those numbers. Yeah. So the total area under the curve is 1. It represents 100% of the data. It does technically go out infinitely far to the left and right. Okay, it represents 100% of the data. Tell you what, let's see. Let me open this up here real quick. Ooh, let's see. Set this to projector mode. Gorgeous. Here's a little Desmos graph that I had put together at one point. So here's a normal distribution. The actual equation for it is crazy sauce. Look at that. That's pretty weird looking. A little bit. Yep. But one of the cool things I can do is I can actually change this. So these represent standard deviations above and below the mean. And so one standard deviation above and below represents 68.268949213.7% of the data, Ben, will land between these two values, okay? If I wanted to go 2 standard deviations above and below the mean, I could drag it like that. And we did some estimates on these earlier. But notice here I get 95.4499736.104% of the data will be plus or minus 2 standard deviations above and below the mean. Okay? And if I go further, right, 3 standard deviations, right, I get 99.7% of the data. If I go 4 standard deviations, I get 99.99% of the data. And let's see, let's actually go to -10 and +10 standard deviations. Eventually, you'll notice that the computer could no longer keep adding more 9s for me. And it told me it's 1, but that's technically lying to you. Because even if I go way out here and I zoom in, technically there's still height above that curve there forever. That's called an asymptote. We'll talk more about those later when we talk about exponential equations. But yeah, it gets closer and closer and closer to 0, but never gets there. It's like been permanently friend zoned, and it like super wants to like hang out and date 0, but 0 is just like, nope. And yeah, with all of their attempts, yeah, just never, ever gonna be out of the friend zone. I'm sorry there. So these curves do, like I said, go on infinitely far to the left and right. But as you see, a majority of the data gets picked up really quick. So 68% of the data, 99.7% of the data is within 3 standard deviations. Now, question, where did this number 34 come from, do you think? Well, these are symmetric graphs. If between here represents 68%, half of 68, yeah, I like it, will be 34. It's a little trickier to figure out where this 13.5 came from. The way you would get that, I'll explain. You would have to have taken the 95%, subtracted the 68%, which would have given you these, and then what would I have done? Divide by 2. That's where that comes from, all right? So I just want to point out that these charts are related to each other, and each of them will work conveniently for you, depending on what you're trying to do. Okay, so let's look at example 1. Yeah, it does get warm in these classrooms on the 2nd floor. Probably money. So, guys, example 1, mis amigos. Silencio, por favor. Sí? Gracias. A normal distribution has a mean, which can be referred to as mu. We also might call that x bar. All right, that's the Greek letter mu, I think is how you'd pronounce it. Actually, my best friend used to call his cat Mewy. Mewy, like the cat meows. Mew, no? All right, never mind. And a standard deviation of sigma. And you guys know how to find standard deviation. That was that crazy long table formula thing. You're going to have to know how to do that on the test. Might be a good idea to practice that during an ACE block. An x value is randomly selected from the distribution. Find, what this is asking for is the probability that it is 2 standard deviations below. All right, quiet. Last chance. All the way up to the mean. So what they're describing is 2 standard deviations below, all the way up to the mean. And they want to know what is the probability that any randomly selected data set would land in between here. How could I find that? Yeah, what do you think? Sure. All right, so this is where the mean is. This is where the mean minus 2 standard deviations are. Let's see, do either of our charts help us? This is a use of what's called the area addition postulate from geometry. You might see that next year. The easiest way I could do that is see, aha, it corresponds to this region here, right? So how could I find that total percentage? Yeah. Add them up. I like it, right? So 13.5% plus 34% is equal to like 47.5% of the data. Yeah? You guys believe it? Believe it or not, I'm walking on air. All right. Let's take a look at these ones. By the way, guys, you're welcome that I already gave you these little graphs pre-printed, so you can just kind of quickly label them. That's lovely. All right. So this is asking, what's the probability that it is less than or equal to the mean? So that would be describing everything all the way forever. Forever. To the left, infinitely far. What percent of the data do you think that would be? Yeah, because under the entire curve is 100% of the data. And this is actually exactly half, because this is symmetric. Divided by 2, that's 50% of the data. I like it. Which also, by the way, is the same answer over here. You guys agree? I'll even shade this one different. That's lovely. Lovely shading. Yeah, I could, I suppose. Tell you what, let's have you guys do these two problems 3 and 4 on your own. I'll walk around to help you in a moment. Okay. All right, so internet friends, scrub forward in the video if you want to see the next more interesting thing. Or take a moment and think about life. So guys, for this first one, the mean is one end of the inequality right here. And the sigma, the mean plus 2 sigma would be right here. So this would be the region we're talking about. Wow, that was a good sneeze right there. Pro tip, when you sneeze, my friend and I, we used to like intentionally add a chew at the end of our sneezes, and we would try to like get the attention of the other. And one time when we were washing dishes at a restaurant, which was our first job ever when we were teenagers, he had like a sneeze that he was milking, and he was all like, hey, look over here. And then like he finally had the sneeze and goes, chew, and like sneezes to the side, and a waitress walked by right then, and not a mist, but visible like mucus globs, globular mucus was like all over the poor lady, and he was super apologetic. So be careful when you're sneezing, friends. But something we would do here. So the fact that this is between the mean and sigma plus 2 standard deviations, right? So that's 2 standard deviations above the mean. I can now compare this to this right here. So it looks like the region I would need are the 34 and the 13.5 being added together is how I would do that. So I'm going to take, and I'm going to add those together. And I believe that's 40. Yeah, there we go. Don't worry. Hey, it's okay to make mistakes. Let's all learn from them. Let's have a community that celebrates making a mistake, because that means you were trying. All right, friends? That means you were trying. Sigma minus 1 standard deviation is right here. Or mu minus 1 sigma. Sorry. Man, I keep saying that the wrong way. Is right there. There's one boundary. And x is greater than or equal to that all the way up to the mean. What do we do? Yep. And that's it. Yeah, just the 34. So that's one way you could do it using this version. If you wanted to use this version, you could have taken the 68 and then what? If I was using this version, divide by 2. Either of those charts work, okay? But you have to be aware of what you're trying to get, okay? All right. So this is 34%. Very good, very good. All right, I'm not 100% sure that we're all fully there yet. Let's do 5 and 6 as well. All right, let's try 5 and 6. Let's see if you guys can do 5 and 6. Did I not print 6 maybe? Oh, okay. Sometimes I have more problems on my version than you have, because I've got like everything, but maybe not everything was good enough for you guys. So yeah, give this a try. I'll walk around. All right, so friendly friends, mu minus 3 standard deviations is right here. And they're asking for the probability that any data point is less than that. So they're talking about this infinite sliver to the left of that. Does anyone have an idea as to how to find that? How to find... Ooh. Yeah, it's just going to be 0.15%, less than 1%. Okay? I was going to say a 15th of a percent, but that's actually a lie. That's 15 hundredths of a percent. My bad. Okay. Oh, you did the other one as well? So this is 0.15%. Another way you could do that is if I added this plus this plus this plus this plus this plus this plus this and subtracted it from 100, that would also work. I could also have used this one, whereas if I took the sum of all of these, subtracted this from 100, and then divided by 2. Subtracting this from 100 would give me just both sides. Let's find out. All right, so this is the values of x that are bigger than, greater than or equal to the mean plus 1 standard deviation. So here's the mean plus 1 sigma. Well, if you are confused, make sure you're writing these things down, right? Make sure you're asking questions. Don't just identify your confusion. Tell me what part. And this actually, goes forever that way. Yep. Yep. But no, he did correctly determine which ones he wanted. So guys, I figure out what region I'm talking about, right? I can shade it in, and then I'm just going to add the components that has together. All right, so 13.5235. Let's see, what did you guys get? I got, oh, they're saying this actually adds up to 16%. Does it? Yeah, 0.35 plus 0.15 is 0.5. Add that 0.5 to this 0.5. That's a full whole number, right? And 13 plus 2 plus 1 is, yeah, 16%. Here we go. All right, so one last type of problem we're doing is now going to have us interpret these types of results. Okay? So here's example 2. So keep moving in your packet. You find it. Yeah, there you go. Isn't that convenient that I put it in chronological order rather than just randomly hiding things? That would be less helpful. So the scores for a state's peace officer standards and training test. Okay, so I don't know what that is, but someone's taking a test, are distributed with a mean of 55. So guys, let's label that. So I'm going to say mu, that's the same as x bar, if you wanted to call that your x bar, is 55. And it says, and a standard deviation of 12. So that's my sigma. All right, so little sigma is equal to 12. It says the test scores range from 0 to a hundo. Then it asks, what percent of the people taking the test have scores between blank and blank? All right, so first thing I'm going to do is actually label my graph with this information. Watch me carefully. So the middle is my mean, is 55. And to that 55, each of these lines is going to be plus 12, plus 12, all right, plus 12, right? These are standard deviations that I'm adding or subtracting. Or over on this side, right, minus 12, minus another 12, minus another. So let's label where those values land at. So 55 plus 12, if you didn't leave space right here, you can write it underneath, that's fine, is going to be 67. 67 plus 12 will be 79. And 79 plus 12, is that what, 91? And let's see, 55 minus 12. Did I do that right? 43. 43 minus 12 will be 31. And I think over here is going to be 19. All right, so what I have to do in this case is I have the mean, I have the standard deviation, but now I'm labeling my normal curve like so. But now they're going to ask me questions about this. Here we go. What percent of the people taking the test have scores between 43 and 67? Actually, the other thing I'm going to do, watch, I'm going to cheat. I'm going to copy and paste our work. So let's shade that. So between 43 and 67 are right here. So they're saying what percent of the people scored between those values? Where are you getting that number? So yeah, let's compare that to here. So that is 1 standard deviation above and below the mean. That's this region here. That's going to be the 68%. Or I could view it as, oh, that was 34 plus 34. This chart, a lot of times, is the more useful one. And even when it's not as fast, it's still pretty fast and easy to understand. So I would expect that 68% have scores between those values. And then it asks question B. An agency in the state will only hire applicants with test scores of 67 or greater. About what percent of the people have test scores that make them eligible to be hired? So 67 or greater. That's everybody over here all the way. And how do you get that? So to find that, I've got this plus this plus this. Actually, I think that was the same work as this here, right? Look at this. Ready? But bam! I'm a super cheater off myself right there. Bam! 16%. Now, what if I told you someone got a perfect score on this test? That would be pretty darn rare, right? Because a perfect score is almost like 4 standard deviations above the mean. That person is like super, super rare, right? It could happen. It's just not going to be likely. Or similarly, like if a person got like a 0 on the test, that's also going to be really rare on the other side, right? Usually people are going to be able to, they'll be scoring something. They said 67 was passing. So only 16% of the people passed this test. But, I mean, they could come back and try again, right? Back and try again. All right. Well, thanks for watching, mis amigos. Have a great day.